Algebra 1, here's our redo of the lesson 11.4 recording because of that weird lag that ended up happening. Yep, so in case some of you maybe tried to start doing that and was like, this is too annoying or is too hard to track with because sometimes like there's a minute that goes by and then suddenly all the text shows up. Here it is again. So this is 11.4 and it's multiplying and dividing rational expressions. Multiplying and dividing. Oop, oh, that'll make it easier. I forgot to scroll up all the way, so I have a little bit extra space to work with. And dividing rational expressions. And this is easier if you can get into the like, I'm dealing with fractions still kind of a mode. Because like with regular fractions, if you are multiplying like 2/5 times um, 4/3. You just multiply the numerators, that gives you 8. Multiply the denominators, 8/15. Okay? It works the same way with this, just we just have more going on. All right, so to add some notes here, we could say multiplying. Multiplying. Well, first, numerators. Numerators multiply. I'll just do mult for short. With other numerators. And then we could say denominators multiply with other denominators. And then before and after multiplying, before and after multiplying, keep an eye out for things that simplify. And that's simplifying like lesson 11.3 kind of stuff. All right, so let's do some examples. First example we have is let's do x to the 5th y over 2z cubed times 18 z to the 4th over xy. Okay, so you can simplify before or after because this is x to the 5th times y times 18 times z to the 4th on top, and on the bottom you have 2 times z cubed times x times y. This is all just a bunch of multiplication, so it doesn't matter that like these are in the top of this fraction and these are in the top of, and like these, the x and the y's are in the bottom of the other fraction. It's all being multiplied anyway, so you can simplify before or after. Doesn't really matter. But if you multiplied first, and you put things in the usual order of the number goes first and then the letters in alphabetical order, this would be 18x to the 5th y z to the 4th on top, and the bottom would be 2xy z cubed. And then at this point, we look for what simplifies. Well, 18 over 2, that's 9, so I'm going to have a 9 on top, a 1 on the bottom. Uh, what else? Okay, the x's is the power, and here's the way I recommend looking at it. It's easier this way, I think. Is the power of x bigger on top or on the bottom? On top. Okay. By how many powers? By 4. So you put an x to the 4th on top. You look at the y's. Y to the 1st over y to the 1st. Y over y is 1. Or you could look at it as, is the power of y bigger on top or bottom? Neither. It's a tie. Okay, is the power of y bigger on top or bottom? Neither. It's a tie, and ties eliminate. Then you look at the z's. Is the power of z bigger on top or on the bottom? On top. By how many? By 1. So we put a z in the top, or technically z to the first. Then at this point, we don't need the over 1 anymore. And we're just left with that as our answer. Now, you could have also done that simplifying with what you started with. And what we started with, we could have said, well, that x, the x's, that'll cancel. That'll drop this down to a 4. The y's cancel. The 18 over 2, that becomes a 9. And the z to the fourth over z cubed. The z cubed on bottom drops the power z to the fourth down 3. So what am I left with? I'm left with a 9x to the fourth z. So you could do it like that as well. Okay, here's another example. This one is y plus 6 times y minus 1 over y plus 2 times y plus 1 times y plus 2 over y plus 1 times y minus 1. Okay, so once again, y plus 6 times y minus 1 times y plus 1 times y plus 2. These are all just being multiplied. And so we can just look for what cancels. And then technically this y plus 2, this whole denominator is getting multiplied by that y plus 1 by that y minus 1. So we should view this as, practically speaking, being in parentheses as well. So then we look at what cancels. Let's say I have a y plus 6 on top. Do I have a y plus 6 on the bottom? No. I have a y minus 1 on top. Do I have a y minus 1 on the bottom? Yes. That with that cancels. I have a y plus 1 over y plus 1, so that cancels with that. And then I have a y plus 2 on top and a y plus 2 on the bottom. That cancels. So what does this equal? This equals, I'm left with just a y plus 6. And that is my answer. Okay, next example. This one looks like this. We have an x squared plus x minus 2 over x plus 2 times, actually, let's see, x plus 2. I'm going to change this. I'm going to change this to, hold on a second. Yeah, all right. I'll do a 4x there, and I'll do an x minus 1 there. And I'm going to change this to an x minus 2. No, I can't do that. No, I'll leave it. Okay. Here's what some of you might be tempted to do. Some of you might be tempted to be like, oh, x over x cancels. Okay, cool. Don't do that, please. Because the canceling like that only works when what you're canceling is being multiplied by everything else in the top or in the bottom. If there's addition and subtraction of chunks going, those chunks cannot be, well, if there's any addition or subtraction of entire chunks. So what I mean by that is this y plus 6, you do have addition there, but it is within one of the chunks that you're dealing with. Y plus 6 is a chunk that is only being multiplied by other chunks. Y plus 6 chunk times y minus 1 chunk times y plus 1 chunk times y plus 2 chunk. You don't have like a plus 3 hanging out there that adds random addition or subtraction. So as long as you don't have any random addition or subtraction, you can just do canceling. If you do have addition or subtraction of entire chunks going on, you can't cancel. So that x there and that x there, those cannot cancel because they're being added or subtracted to stuff. what we can do is we can check and see, does this numerator factor? And let's see what that would factor to. So I have a minus 2 there. I have a 1x, right? A 1x squared, a 1x squared. So I'm looking for two numbers that multiply to be negative 2 and add to be a positive 1. Well, a positive 2 and a negative 1. Positive 2 times negative 1 multiplies to be negative 2. Positive 2 plus negative 1 adds to be that positive 1x that I had there. So because this is a 1x squared, I can jump straight into x plus 2 times an x minus 1. So this gives me in my numerator now an x plus 2 times an x minus 1. And I have now this times 4x going on. And then the bottom, I have this x plus 2, but it's that whole thing times this x minus 1, that whole thing. Now we can look to see if there's anything that cancels. X plus 2 over x plus 2 cancels, x minus 1 over x minus 1 cancels, and we're left with just 4x is all that's left. Okay, so there are a couple examples of multiplying. Next, let's look at dividing. Dividing. All we have to do is invert and multiply, just like you would with regular fractions, right? If you had something like 2/3 divided by 1/6, well, that's the same thing as 2/3 times 6/1. Hopefully that rings a bell. And because it's like if you have a cake and you divide the cake into two pieces, how much of the cake do you now have? You now have a half of a cake if you take one of those pieces, right? So all that to say, like dividing by 2 is the same thing as multiplying by a half. Same thing here, dividing by 6, cutting a cake, taking 2/3 of a 2/3 of a cake, and cutting each of those into, or dividing, no, dividing by 6. That's going to get confusing if I use that as an example, so I won't. So 2 times, now we just multiply. 2 times 6 is 12. 1 times, or 3 times 1, and my denominator is 3. So what is that? That's 4. Okay, same just works here. So what we can say is first invert, that got weird with that H there, invert the second fraction and multiply instead of divide. Then do the rest just like above, the multiplying stuff. Okay, a couple examples here. So this would be like, let's do 8 over 3x squared divided by 4 over x. So the first thing we need to do is invert and multiply. So we need to take this, the first one stays the same, 3x squared. Now instead of dividing by 4 over x, we multiply by x over 4. So what do we get in our numerator? 8x. What do we get in our denominator? 12x squared. Now we look to see how we can simplify. Well, let's see, 8 over 12, if I cut both of those in half, I get 4 over 6. I still have even numbers, so I can cut them in half again, and 4 over 6 becomes 2 over 3. The other way of looking at that is, oh, I can count by fours, and I can go 4, 8, 12. 8 is 2/3 of the way to 12, counting by fours, so 2/3. And then the x over x squared, where's the power bigger? In the bottom, by how much? By 1. So I put an x to the first, and then I write this maybe a little bit more cleanly, just as, 2 over 3x. Now, a note of caution. The x here is in the bottom. You cannot write this as 2/3 x because this x is the same as, that's a parentheses equals 2x over 3. That's what 2/3 x is. 2/3 x is the same thing as 2/3 times x over 1, so the x goes in the top. That x is in the top. What we have here, the x is in the bottom. Have to keep the x in the bottom. Have to make it clear with your fraction sign that the x is in the bottom. So please be careful of that. All right, that's that example. Here's our next example. We have y squared plus 6y plus 5 over 6y plus 6 divided by y plus 5. Now, this y plus 5 is in parentheses because we're dividing by that whole chunk. We're dividing by y plus 5. If there were no parentheses here, we would be dividing by y and then taking whatever that is and then adding 5. But we're not doing that. We're dividing by y plus 5. Now, it can be helpful to view y plus 5 as technically being y plus 5 over 1. Now it's easier to do our invert and multiply. So we still have our y squared plus 6y plus 5 over 6y plus 6, but now we're multiplying by 1 over y plus 5. Okay, nothing jumps out for how we can simplify this yet. So I'm going to have to do some factoring. So let's look for what can factor. So let's take this and let's factor it. And let's see. So I'm going to look for, I have a 1y squared. So I'm going to look for two numbers that multiply to be 5 and add to be 6. Well, 5 and 1 multiply to be 5 and add to be 6. So that tells me this top part factors to be y plus 5 times y plus 1. Okay, great. And then the bottom, can I do any factoring here? Well, they both have a 6 in them, so I can factor out a 6. That's the same thing as 6 times y plus 1. Because if I re-multiply this out, 6 times y gives me 6y, plus 6 times 1 gives me 6. And then what do I have in the top? I have a times 1. And what do I have in the bottom? I'm multiplying by a whole y plus 5. Okay, so let's look at what cancels. Y plus 5 and y plus 5, that cancels. Y plus 1 over y plus 1, that cancels. And I'm left with 1 over 6, 1/6. A way that you can check like this answer, or really a way that you can check any of these, you can check this answer by picking any number you want to plug in for y and go back to what you started with. Let's just say you say like y equals 2. Okay? If you say like y equals 2, we'll say if y equals 2. Well, let's see what we get. We have 2 squared, right? So that's 4. 2 squared, 4. Plus 6 times 2, that's 12. 4 plus 12 is, 4 plus 12? 4 plus 12. That is 16 plus 5, that's 21. So we have 21 over, if y is 2, we have 12 plus 6, that's 18. 21/18 divided by, what do we say, y is 2? 2 plus 5, that's 7. Okay. Well, 21/18 divided by 7, that's the same thing as 21/18 times 1/7. Now the 21 over 7 simplifies to 3 over 1. So that gives me 3 over 18, which reduces to 1/6. You can check the same thing with one like this, and you can say, well, if I'm right, I can plug whatever number I want in, and it'll simplify to be the same thing. So then let's check maybe if x is, we'll go with x is 2 again. We'll say if x is 2, then I'd get 8 over 3 times 2 squared. 2 squared is 4. 3 times 4 is 12. Divided by 4 over 2. Okay, well, that's the same thing as 8/12 times 2/4. And so 8 times 2 in the top, that's 16. 12 times 4, 12, 24, 48. So what does this reduce to? I can divide everything by 2. That gives me 8/24. I can divide by 2 again. That gives me 4/12. I can divide by 2 again. What did I say? 4/12. That gives me 2/6, which is 1/3. 1/3. Now, with what I have here, if I plug 2 in for x again, what do I get? I get 2 over 3 times 2. That's 2 over 6, which is 1/3. So I get the same thing. And if you want to, you can check your answers like that. All right, let's do another example of dividing. Actually, no. We're not going to do another example of dividing. We're going to look at unit conversions. Unit conversions. And what we're going to do is we're going to use multiplying by 1 and simplifying / canceling. That's going to be the tool that we're going to use. What do we mean by multiplying by 1? Well, anytime what's on top equals what's on bottom, that's equal to 1. So, for example, 7 days over 1 week, that's the same length of time. So that equals 1. Even though the units are different, practically speaking, it's equal to 1 because what's on top equals what's on bottom. We could say like 1 yard is the same thing as 3 feet. Equals 1 because the length on top is the same as the length on the bottom. If we're dealing with length, we could also say something like 1 mile is 5,280 feet. Or we could say like 52 weeks is equal to 1 year. Right? All these are equal to 1. So what we do, let's do an example. Well, we use, again, like I was saying, a simplifying canceling as a tool by if we have a unit that we want to get rid of and we want a new unit, and like the unit we want to get rid of is on top, then we can put that same unit on the bottom when we multiply by our fraction equals 1. And let's just say like feet on top and feet on bottom will cancel with each other, leaving us with the new unit. That'll make more sense with an example. So let's say something like if 1 mile equals 5,280 feet and 1 meter equals 3.28 feet. MI dot is the abbreviation for miles. M is the abbreviation for meters. So please don't just do M for miles. The only time that you can do M for miles is MPH, because that is just the common abbreviation for miles per hour. But other than that, if you're just abbreviating miles, MI dot. Okay, and let's just say we also know that 1 kilometer equals 1,000 meters, and we also know that 1 hour is equal to 60 minutes. And we also know that 1 minute is equal to 60 seconds. S or SEC. Okay, so if we know that, let's convert 50 miles per hour to meters per second. So what we do is we start out writing what we have as a fraction. So we have, oops, that's not a 5. So we have 50 meters on top, or sorry, not meters, 50, wow, sorry about that, 50 miles on top. And what's on the bottom is 1 hour, because it's 50 miles per hour. And we want to get to having meters on top and seconds on the bottom, because we want meters per second. So what I can do is I could use these different conversion factors. So like I want to get rid of miles and end up with meters. So I know I want to get rid of miles. So I want to multiply by some conversion factor that puts miles on the bottom. So I look and like, okay, what conversion factors do I have that have miles? Well, I have 1 mile equals 5,280 feet. So I'm going to put 1 mile on the bottom because now my miles will cancel. And what do I put on top? What 1 mile equals? 1 mile equals 5,280 feet. Okay. All right. It's just theoretically a step in the right direction. I know I'm no longer dealing with miles, but I want meters. I currently have feet per hour because feet is what's left on top, hours is what's on the bottom. So I need to get rid of feet. And hopefully, well, at the very least, I know we want to get rid of feet. I don't want to use the conversion factor that I just used because that'll take me back to miles. So what else do I have that has feet in it? Let's see. Well, I have this one that has 1 meter equals 3.28 feet. So if I put the 3.28 feet on the bottom, now my feet on top and feet on bottom cancel, and 3.28 feet is equal to 1 meter. Cool. Now I have meters on top. That's what I want. But I want seconds on the bottom. I currently have hours on the bottom. So I got to multiply again, and I got to get rid of hours. So I want hours on top. So this one has hours. So I'm going to put 1 hour on the top. Now my hours cancel because hours on bottom and hours on top cancel. And 1 hour equals 60 minutes. 60 minutes. So now my units are meters per minute, but I didn't want meters per minute. I want meters per second. So I got to get rid of minutes and get seconds. So I currently have minutes on the bottom. I want to get rid of them, so I'm going to use this one that has minutes. So that gives me 1 minute. My minutes on the bottom and minutes on the top cancel, and 1 minute is equal to what? 60 seconds. So now what units are left? Meters on top, seconds on bottom. That's what I want. So on my calculator, what I'm going to do is on calculator, I'm going to do 50 times 5,280 divided by 3.28 divided by 60 divided by 60. The reason why is because we're dividing by 3.28 and we're dividing by 60 and we're dividing by 60 again. Okay? So anything that's on the bottom, you divide by. The other way of doing that is using parentheses. You could do, or you could do 50 times 5,280 divided by parentheses 3.28 times 60 times 60. Because putting all this in parentheses with the division sign in front of it says we're dividing by all of this. You'll get the same thing either way. And what you will get is 22.4. So our answer here would be 22.4 meters per second. That is your answer there. Okay? And there's one other kind of problem that the lesson has, black, and it is like this. Find the product and describe the meaning. Find the product and describe the meaning. And here's what we have. We have $3.50 per one coffee times 4 coffees per 1 week times 52 weeks in every 1 year. Okay. So what you would do is you would look at, well, what units cancel? Let's see, coffee and coffee cancels, weeks and weeks cancel. So then what you're left with is, when you multiply the numbers, 3.5 times 4 times $52, what we get is $728. Oops, $728. So what are my units? Um, well, dollars, right, on top, and then per year. And then they'll like describe the meaning. Well, what am I talking about here? I'm talking about for coffee. So if you spent $3.50 on each coffee and you got 4 of them per week, every week of the year, you would be spending $728 for the year. All right? So that's each kind of problem for this lesson. Hopefully it goes well. Talk to you later.